Uh, Welcome, folks, to DevOps Reframed, embracing the path for developer productivity engineering. We have a lot of cover to ground, just 157 slides. No reason not to do it in whatever hour and 15 that we have. Let me start with conspiracy theory. I hope we will be somewhere in like this area, which is kind of grounded in reality, because I do have proof. So my conspiracy theory goes as follows. DevOps is a conspiracy by ops people to make us, the developers, work harder. Are we developers, all of us? Yep. No? What are you doing? Oh, perfect. You will be our scapegoat. We will blame on you everything. This is brilliant. All right, what about you? Developer, excellent. Okay, so we are the majority here. We can totally bully this guy. Excellent. All right, that sounds like a plan. My name is Baruch Sadogurski. I'm at jbaruch everywhere on the internet. A developer productivity advocate with Gradle. And my path was, I've been on both sides of the field. I worked as a developer for like 10 years, and then we shifted with the company named JFrog that you all probably know to DevOps, and I spent many years in this area. So I kind of experienced both sides. And now I'm doing advocacy for developer productivity engineering, #DPE. And this is a lot of what my talk is about, like the combination of three of them and where do we meet. So I wrote a couple of books, DevOps tools for Java developers. This is exactly my spot, Java developer doing DevOps. And Liquid Software about the future of how we are going to release software. The most important slide of this talk is this one. If you go to speaking.jbaruch, you will find there the slides. That's what I usually say, but you won't because of technical difficulties. First, I procrastinated, and then the internet wasn't great. But I promise I will upload the slides as the second we finish this talk. The video that I record, and I will also upload it right after. And all the links to everything that we're going to mention, all the books, all the papers, everything is going to be there. So to make it easy for you to remember, you don't need to take pictures. It's on the bottom of every slide right here, together with my social handle, #DPE, Developer Productivity Engineering, and the handle of Dev2Next, in case you have the unstoppable desire to praise this talk on the internets. Don't forget to mention the right stuff. All right, so yeah. As I mentioned, developer like many years ago, but yeah, with Java, so I know exactly what I'm talking about. Exhibit A, my proof for the conspiracy theory is this. Who heard about the Phoenix Project book? Obviously the platform engineering guy, but also a couple of developers. This is the most important DevOps book ever. Like if you want to understand what DevOps is and you want to read one book, which is also a novel and not like a boring technical book, this is the book to go. It's absolutely awesome. It borrows from another book called The Goal, which was an explanation of theory of constraints, another very important pillar in how we write software today. And this is also kind of a should I say, like a next step in those novels that try to explain hardcore business processes in a fun and engagement way. So I really, really recommend this book. But the reason it's here is because the cover of this book, which kind of has all the main characters of the book, proves my point perfectly. So let's look, who do we have on the cover and who do we have in the book? The text is a little bit small, I'll read it out loud. So this is Patty, and Patty is the director of IT service support. She's in ops. This is Wes, and he's director of distributed technology ops. So obviously in ops. This is Sarah. She is like the main antagonist and like the evil lady. She's in sales. Well, obviously it all makes sense. Steve, who is the CEO and acting CIO, which is fine. Dick, CFO, okay. Now, Bill Palmer, he is the main protagonist. He is the guy who kind of invents DevOps and transforms the entire organization from failure to success. And he is obviously an ops guy. He is a VP of IT Ops. Eric Reed, he's the board member. He actually pushes Bill towards discovering DevOps by pitching him the theory of constraints, which is explained in the other book, The Goal, and it's all like interconnected. And then we have Brent, who is a lead sysadmin, obviously ops, and the John, the security guy hiding over there so he won't be beaten to death by developers. It all makes sense. When you look at it, what do you see? Or what do you don't see? Developers. Where are the developers? A book about DevOps, and there are no developers on site. Well, they kind of are, but they are not pictured in a very nice light. Those are the folks who kind of get up from their desk at 5 p.m., throw like the keyboard and shut down their computer and go home, leaving ops with all the crap that they developed during the day to try and get it to production, right? So, well, basically, yeah. When we talk about who really kind of came up with DevOps, care about DevOps, push DevOps forward, those are obviously the ops people. Now, the question is really why? What was the need of the ops people to come up with DevOps and try and push it? So, first of all, what is DevOps anyway? Quora, many years ago, been asked, hey, as a Linux system administrator, how do I shift my career to DevOps? And then some person who is a DevOps online trainer for many, many years says, well, you already know Linux fundamentals, so this is good. All you need to do is learn concepts like AWS, and then Maven, Jenkins, something called Gits, and voila, you are a DevOps engineer. So basically, Linux fundamentals plus Gits equals DevOps engineer. You know what? That sounds like a very nice career move because you actually move from this to this. Just by learning Linux fundamentals and Gits. Well, and then it looks like it's a story about money because next thing you know, there are explosion of DevOps engineer careers, even in our very hard times of like economic downturn and layoffs and what's not. And an entire industry of certifications for DevOps engineers, which all about using tools to do ops stuff or system administration stuff. But now instead of kind of working on each and every Linux server, we do it in herds. We have like Kubernetes and stuff. But eventually it's like system engineering work just reframed as DevOps engineer. Now, I personally get absolutely mental about the whole DevOps engineer thing, and we'll get about it later. This is like my biggest obsession, that DevOps engineer is not a thing. We'll get to it in a second. But before that, I want to ask why once again. Why the whole idea of, hey, we will automate some stuff that system administrators did, and then suddenly it will become this huge thing that DevOps is, requires going deeper than just saying, hey, the salary is higher. But why the salary is higher? Why suddenly everybody are so in such a high demand? And, you know, if we ask why enough times, we can get to promote it to an engineering manager eventually. But we'll stop it here at 2. So what's going on? Now, this is what we call DevOps infinity loop, right? So you see here stuff like we plan, and then we code, and then we build, and then we test, we release, we deploy, we operate, we monitor, and after we monitored and we discovered what needs to be done next, we're doing it one more time, and infinity actually times. So, does this look familiar to anyone? What does it look like? What does this look like? Thank you very much. I didn't pay him. This is exactly the same thing, right? We plan, we code, we build, we test, but, and this is like something that developers do all the time, but then ops people decided that, hey, how about you do all our work as well? Because we finish when we code, but then suddenly all the release, deploy, operate, and monitor is also part of our job, somehow. But is it really? So here is State of DevOps report, which is the most important, I would say, kind of a research vessel to understand DevOps for the entire industry. It started many years ago in 2015, almost 10 years, had some permutation, started in Puppet, and then went independent, and then Google Cloud bought them, and they still publish, and they're very profound in their findings of what's going on. What I want to show you is not the state of DevOps, but I want to show you what questions do they ask, because this is very important. So here is they have a breakdown of elite, high, medium, and whatever, mediocre performance. Never mind. What I want to show you is this. This is how they break down what needs to be done. And you see here new work, and it's in bold, and it's in caps, and it actually makes perfect sense because this is where the money is, right? The money is in new projects. The rest of it's stuff like unplanned work and rework, that's like whatever your bugs or what's now, remediating security issues, working on defects identified by end users, customer support work. This is all makes sense. The devil is in the details. Let's see how this work is defined in the DevOps report. So what type of work exists according to DevOps report, etc. So planned work, that's your new work. Business projects and new features. This makes total sense to us as developers as well, right? This is what we do, we write new features. But then things start to get interesting. Internal projects are defined as server migrations, software updates, and so on. Changes defined, driven by feedback on complete work, this is fine. But then again, unplanned work is defined as support escalations and emergency outages. I mean, server migrations, emergency outages, this is all very fascinating, but this is not developer work. So is DevOps really has something to do with developers? This is all ops. Types of work according to developers will be new features, writing code, and then refactoring, writing code, and then bug fixes, which is writing code. No server migrations, no outages. This is our world, and it is not expressed in the entire thing that is called DevOps at all. Not in the Phoenix project, not in the DevOps State of DevOps report. Where are the developers in all that? So I think by now I proved to you entirely that DevOps is a conspiracy by ops people to make us, the developers, work harder. If we say whatever DevOps is, or whatever their type of work is not what we are doing as developers, what are we doing as developers? There are a lot of definitions, and the definition that I really like is the Manifesto of Software Craftsmanship. It has issues with the original authors and what's not, but in the end of the day, the sentiment that it expresses, I think resonates with every developer. Not only working software, but also well-crafted software. Do we care about the quality of our code? Of course we do. Not only response to change, but also steadily adding value. Yes, we need to do something meaningful. Not only individuals, but a community of professionals, of course, and not only customer collaboration, but productive partnerships. So this totally makes sense, but let's look at it closer and kind of bring it down to definition of done. What does it mean for us, the developers, to do a good job? So here's a list that I came up with, and I hope you will agree. It's stuff like, we understood what the requirements are, we write code that is good code, clear code, and maintainable code. Obviously easy to deploy. We are in no way enemies of the ops people or want to make their work harder. We want our code to be easy to deploy, so when we do go home at 5 p.m., the ops people will have very easy time to deploy. Non-functional requirements are met, and our code is capable of taking the load, and the security is taken care of, and all this stuff. No new technical debt, and maybe we clean some technical debt on the way, and tests are passing, and good coverage. It makes the quality assurance people happy with the quality of our code, and our team lead is happy with the scope that we did, and eventually the product owner is happy, which for us is a proxy for our customers, and they are happy as well. Does it make sense? It does, right? Okay, so this is our definition of done, and here I want to ask you a question. Do you remember this? Many years ago, I would say like 10 years ago, there is this silly notion that developers and QA are somehow antagonists and have this weird adversarial interaction. Do you agree with that? Someone thinks that QA is our enemy?
Not anymore.
No, right? No, not anymore. This is stupid and silly. Of course, we are on the same team. We both want the same. We want better quality of our product. And testers and QA people are actually helping us. Yeah, so I asked that. Now, it's absolutely the same with the ops people in the end of the day, right? We have the same goal. We want to deploy our code to production. If it's not deployed, it's absolutely useless. So we are, as we friends with the testers, with the QA, we also are obviously friends with the ops people. So since we do care about the quality, as we just said, we need to make sure that we provide quality service or quality product, but what is quality? How do we define quality? I will give you an example of how this definition changes. Let's go back in time. This is how the Chase website looked back in, I have it right here. No, I don't have it right here. I have it somewhere on the slide. I don't remember, many years ago, like 10 years ago. It wasn't very useful back then, right? I could check my balance maybe, and maybe see transactions, but that was pretty much all. If I wanted to do something significant, I just got on my feet and went to the branch. So it was nice, but it wasn't mission critical. And if I saw here something like, well, 12 hours maintenance window for website update to ensure quality, I would say, well, this is reasonable. I mean, it doesn't matter. I can check my balance tomorrow. It's no harm done. But obviously, this is not the quality expectations that we have today from our bank, right? I personally switched banks over the quality of an app. Right? I didn't like the app. I didn't like the user experience. It was enough for me to take my money and go to another bank. So obviously the requirements of quality are changing. And whatever was good enough 10 years ago are not good enough today. It's also not only about the quality of the code. the amount of data that we work with skyrocketing, and it's going to be even worse or better, depends on how you look at it, as the time passes. And now, obviously, with AI and LLMs, the amount of data that our application crunch is absolutely mind-boggling. So yeah, that's kind of a survey by Seagate, and they make storage, so they're kind of biased. But you know what? It's okay. Even if we divide it by whatever you want to divide it, it's still absolutely mind-boggling, because the ZB stands for zettabytes. And what is big data for us today? In what units do we operate? Petabytes, right? Petabytes are big data. Like Google storage have petabytes of data. Now, zettabytes is not even the next unit. The next unit is actually exabytes. And after exabytes, there is zettabytes. And by 2025, which is fucking next year, Seagate predicts that we will have hundreds of zettabytes of data out there. What it means for all of us, for each and every one of us, that even if we don't work for Google or Amazon or Microsoft and working on a smaller scale, still we now operate the amounts of data that were inconceivable 10 years ago. And that, by definition, means the death of the staging server. Because what is staging server? Staging server, it's a server in our control that completely simulates our production environment. And it's very convenient because we can test on it without our users being affected and make sure that our software is perfect before we take it to the server, which exactly looks the same and behaves the same in production. Now, obviously, it's not practical to stand up those servers with the same amount of data as our production servers, because it will be too expensive. So we don't do that. Our staging servers now resemble production servers less and less. So what we can do? We can panic and start testing in production. There is an entire industry around testing in production, or what it's called, like in other terms, canary deployments or progressive delivery, that the entire goal is actually testing in production on live customers. The goal of this industry is, and that's my favorite term on this slide, is, where is it? Let me find it. It's right here in small, but yeah. Reducing blast radius. Here it is, larger. Reducing blast radius. Now, think about it. We are talking about production. We are talking about paying customers. And all we try to do is reduce the amount of customers that will suffer from our bugs. We're not talking about eliminating blast radius. We're not talking about, yeah, you know, we will have some confidence. No, or we're talking about, okay, let's try and minimize the amount of people that will suffer from our releases. But it is what it is. We cannot test in any other place than in production, because only the quality that our customers see and experience is the quality that really counts. Many years ago, we could say, okay, we are sure that the quality that we see at 3 p.m. in our staging before we are going home, it will be the quality that the customers will see, but not anymore. Now, the only real test is what the customers see. And the only place we can run this test is in production. And that means that production is now part of our experience as developers. We cannot say, well, I don't care about production, my staging is good enough, so my job is done. Suddenly, we have to be there when the shit hits the fan. When our software is released to production. I said the same thing twice. But okay. So now you have to be on call because you have to be there where actually suddenly the customers will discover stuff that we released. So there is now in our definition of done a new line. DevOps are happy because they are the ones who are in charge in operating our software in production, and they need to be satisfied with the quality of our product. Now, obviously, getting back to who is this DevOps person anyway, brings us back to my obsession with the term DevOps engineer. Right? DevOps engineer is not a thing. It's not a thing because it makes as much sense as collaboration engineer. Because DevOps is a collaborative practice that teaches people how to work together. It's not an engineering practice, so there are no such things as DevOps engineers. Now you can say, well, but who cares? You are splitting hairs and let them call themselves whatever they like. But naming have very significant implications. Because after you have DevOps engineers, the next thing organization does is put them in DevOps teams. And you might think that this is how the DevOps team looks like, but in reality, this is how DevOps teams looks like. So who are familiar with the TV show Silo? No. It's a TV show on Apple TV, and the description of this TV show is dystopian TV show about how in a ruined and toxic world, thousands live in a giant silo. Well, it's basically a documentary about the DevOps team. When you put DevOps engineers together, you create a silo that the entire notion of DevOps tried to break down. Because next thing you will try to do is break the silo between developers and the new created DevOps teams. And we can call it DevOps. Because that's how we will have a collaboration between Dev and DevOps. It is as stupid as it sounds, and it all starts with the toxic term DevOps engineer. But there is an engineering aspect of DevOps in the end of the day, right? There is like someone has to configure those pipelines that the developers release their software on. And those people have a name. This is a very old video of my friends Seth Wargo and Liz Furjon speaking about SRE. This video is like 15 years old. And Google came up with this term, and you would assume that Google would be better in coming up with terms because SRE, that stands for Site Reliability Engineer, is a terrible name for someone who does the engineering aspect of DevOps. No one wants to be Site Reliability Engineer, and I'll tell you a true story. When I worked in JFrog, and I was obsessed with like DevOps engineers do not exist, one day I saw an opening on JFrog's website for DevOps engineer. And honestly, I completely lost my shit. And I went to complain, and I'm like, people, we are DevOps company. We should understand that DevOps engineer is not a thing. How are we even putting that? We are like, it's just wrong. We shouldn't do that. And the answer that I got from the hiring manager was very simple. Look, no one wants to be site reliability engineer. Because when I say to people, hey, do you want to be site reliability engineer? They're like, no, I'm not interested in making sure your WordPress is up. Because this is what they hear. Site like a website, and reliability like keeping it up. They're like, we want to do like real DevOps job. We want like Kubernetes and stuff. So this is just a very unfortunate term that in my view did a lot of damage to our industry and hurdled the propagation of true DevOps, the collaboration methodology, for many, many years. But good news, we have a solution. And the solution is platform engineering. How it is a solution? It's another term which is closely related with the engineering aspect of DevOps. And here's, for example, Scott Shaw, who is the CTO of in ThoughtWorks, mentioned that as well. DevOps engineers are rebranding themselves as platform engineers. And I'm very happy for that, and people are very happy for it. Everybody wants to be platform engineer, right? Yeah. Because it's a great term. It's a really, really good term, and you can see how tons of results, like millions of results, talking about exactly that. How is platform engineering different from DevOps? Platform engineering versus DevOps engineering, and all this kind of stuff. All right, there is the internet now is full about the discussions of what platform engineering is, and there are different definitions of it. But in the end of the day, the word platform there does the heavy lifting, and this is why it's so much better than DevOps engineer, because platform, it's exactly what DevOps as a collaborative practice runs upon, right? So if you ask ChatGPT, what is platform engineering? It will tell you it's about building and management, scalable infrastructure, and services that enable developers to efficiently deploy and run applications. This is perfect. In a sentence, this is the person who writes all the YAML files for Kubernetes for you, which is great. All right, so yeah. In the end of the day, the developers have to deploy to production. We spoke about it, because the production is the only place that actually matters. And the engineering aspect of DevOps is building a platform that will enable developers to do that. And platform engineering here is really brilliant. So in the end of the day, platform engineer is a very successful, and I'm very grateful for this rebranding of the failing term of SRE. So back to this slide, well, we need to make sure that platform engineers are happy with our code, because now our code needs to be deployed to production using their platform, so it needs to be compatible with this platform. But not only. What makes platform engineers happy? And we have a platform engineer here to confirm or to deny what I'm going to talk about. Our code is modular. It's important for it to be modular, because when some parts of the application don't work, we want to be able to swap only those parts. It is deployable, easily deployable, because when we are on call and there is a blast radius and customers are suffering, we want to deploy a fix as fast as possible. It is observable, because figuring out that something is failing from Twitter is not the most efficient way of get feedback. We want better feedback. It's scalable, because when we need to ramp up the load of our application, it needs to be able to do that. It's upgradable, because when we want to deploy a fix, it needs to work with the rest of our application very easily. It's also downgradable. If we decide, instead of deploying a fix, rolling up a previous version, the rest of the application should be forward compatible and be able to work with the other version. And this also is a very familiar list. This reminds me, at least, of the 12-factor apps, which was the cornerstone of the entire movement of what we now call cloud-native applications. It's exactly the same concept, described a little bit differently from a different perspective, but in the end of the day, what is required from us, the developers, is running cloud-native applications that are capable of being very agile in production. And that means that we as developers now really part of DevOps, because not only we care about our code, we care about tons of aspects which platform engineers care about, and this is exactly where we meet together. Another hot take, we already know all that. It's been more than 15 years that we working on how DevOps should work. And we know all that. What I told you in this half an hour, it wasn't in any way revolutionary or mind-blowing or new. Agreed? I mean, maybe I made it more organized for you all, and I would be very happy if I did, but none of that is new. And yet, this is how most of the developers feel about DevOps. That they are forced to do something that they don't like, that is out of their scope, and they are not entirely bought into. After 10 years of trying, developers still aren't excited about DevOps. And the question is, how do we change that? How do we go from this to this? Funny story, GIFs that go from sad to happy do not exist. I don't know what it says about our society, but I searched for hours, and there are tons of GIFs that go from happy to sad in a second, but not the other way around. So I had to reverse the video to make her to go from sad to happy. There is a profound revelation about our society somewhere there. So let's see what did we already figure out and what is still there to improve to make sure that developers are on board with the DevOps train. So back 15 years ago, this is how we describe DevOps. It's Dev and Ops and QA all coming together to do something. It was very vague. There are no concrete actions or terms here, and no one really understood what's going on. And then we started to think about DevOps as an intersection of people, process, and tools, namely improving in how people work, in which process, which with tools. And over the years, we figured that out and we have answers. It's about productive people working in the framing of productive process, using productive tools to release our code faster, more reliable, more agile, etc. Now, we figured out some of that. So, for example, we know exactly what productive process we want to work with. And this is our empowered teams. And those are the teams in which platform engineers and software developers and QA people and product people and security people all work together towards a product or a feature, and then it is built together, released together, operated together. This is your empowered team. We know exactly how to do it. Productive tools, well, kinda, sorta, to an extent. Everybody loves to give shit to Kubernetes, but it is really comparing to the alternatives of how we used to do ops 20 years ago. This is a really step forward in productivity when we talk about productive tools. Now, what about productive people? What make people productive, and where are we in this journey? So first of all, the pain is real, right? So for example, builds and tests are slow, and it's hindering productivity of 90% of the people that we are asking in our survey. And there are more than that. There is also root causes of our failures are completely obscured and unknown. And we don't have observability on performance of our builds and tests and infrastructure. There are tons of obstacles for people being productive. And this is, for me, our next frontier. Our local environments are the production system of our production system. And when we figured out how the production systems work, how to observe them, how to release, how to write code that it's good to our production systems, now it's time to look on what makes us productive. And there are a lot of answers. One of them is developer productivity engineering. Developer productivity engineering is the engineering discipline that is focused on making developers more productive. And it's built on 7 tenets. First, and the most important, is foster faster feedback. How do we make our code, the feedback on our code, faster? Eliminate toil. Now look how we take the DevOps principles and shift them left towards the developers. Eliminating toil is one of the core tenets of theory of constraints, the goal, and then DevOps with the Phoenix project, and now developer productivity engineering. Collaborate through effective tooling. We just spoke about productive tooling. We need to make sure that what we work is as productive as well. Prioritize automation and eliminate bottlenecks. We do it for our production environments and for our path in production. It's time to do it for our developer environments as well. Observability. Our production is fully observable. How about our development environments? Dedicated organizational mindset. It's very important to focus proactively on developer productivity engineering and outcomes over output. Just to give you an example what I mean here, your build log with an error that spills endless stack traces is output. The one line there that points you to the line of code when you had a bug, this will be outcome. Think what difference that makes. So let me show you some examples of how small developer productivity engineering improvements make a huge difference on our productivity. For example, when we use better IDE. Think about what happened if you had to write your production code in Notepad. This is exactly that. By building and using better IDE, we engineered our productivity. Testing better. Integration testing is a very important part of our feedback loop. We want to know if what we wrote will work with our database. But having database environment to test our code is expensive, cumbersome, hard to get, hard to monitor, and it's definitely slowing us down. Test containers is a project that makes very close to the real thing integration testing fast and reliable, and actually shift left as much as possible. It's in your IDE. You can spin up your integration environment for your test on your machine. This is engineering. It's a software project that improves our developer productivity. Better code. We spoke about better code, that it's part of our requirement anyway, but it also makes ours more productive when it comes to maintenance of our code. Engineering better code to begin with is a huge improvement in developer productivity, and tools like Sonar, SonarQube, and all their suite actually allows us to enforce better quality during development in our local environment, which is also very, very cool. Flaky test detection. Flaky tests are a huge killer of developer productivity. When the tests fail, when they shouldn't, it really stops us and slows us down. So if you could detect which tests are flaky and then make sure to fix them, that will improve our developer productivity, and again, it's an engineering thing. And what I started with, foster faster feedback. Let's talk about feedback. So there are actually two types. Before that, we as developers, we heavily rely on feedback because we want to know if what we are writing is correct. Getting back 50 years ago, when people had to run their code on mainframes and they had 30 minutes available in a week to run their code and check that it worked, that was not a very efficient way to work, right? So you did all your calculations in your head, you compiled in your head, and you planned ahead, and then you had this window of 30 seconds of run it and see if it works. Today, we got much better with developer productivity, and we actually have a sub-second feedback for our code. If we write string instead of spring, or spring instead of string, our IDE will alert us immediately in a sub-second feedback efficiently. Our build, we wrote our code, and now we want to get feedback locally, immediately, whether our code is good or not. We run our local build, and we expect it to be fast and give us good feedback. And then we give it to CI, and here it starts to really take longer. But we also care less because we won't work for it, and it's fine. Production, the feedback from production might take hours or days depending on how fast we release. And again, this is an important feedback, but it's actually longer. So this is how it works, right? It's a reverse dependency on the instance from developers. The closer left it is, the faster feedback we expect. Now, generally, it kind of works, except of build. Build stands out as being very, very knowingly slow and annoying. You obviously all know this XKCD comic, but frankly, I don't think that's the case. It might be the case for the first time, when it's fun. But if your build is continuously slow, you don't have any fun. You're annoyed with the build being slow, and you're really upset with it and don't have any fun at all. It is annoying when the build is slow. Now, the other problem is that build is a very specialized tool. The great Bruce Eckel once wrote a very, I would say, controversial post about Gradle, how terrible Gradle is. And his take from it, which is very profound, is to do anything, you have to know everything. Now, this is especially true about Gradle because it's very open to the developers and allow you to do a lot of stuff. But frankly, it is true for every build tool. Even with Maven, that will hide the complexity from you, the minute you want to do something which is more trivial than add dependencies or repositories, you get into the depth of Maven to discover that it's not less, but even more complicated than Gradle, because trying to hide the complexity from you makes it ugly on the way. So, generally, build is a complex domain that the developers are not the experts. So not only it is slow, we don't know why, and frankly not very inclined to go and learn, because this is not our domain. So what is build? Build is a process that takes care of multiple steps. It sets up the project, and then it downloads the dependencies, and then it generates artifacts. If it will be Java, it will compile. If it's like JavaScript, it will just bundle them together. And then it runs your tests, and then it deploys the artifacts somewhere. Usually deployment from your local build will be your local storage, and there is like an aspect of deployment as well. So what can go wrong? Well, each and every step. Everything can go wrong. When? At any time during build. So obviously the build frustrates the developers. It is slow, it is unstable, and it drives us mad. So let's ask ChatGPT again. What techniques can I use to speed up a Maven build? The first advice from ChatGPT is skip tests. Not the greatest advice. And it's not the greatest advice because it defeats the purpose of the build. You're running local build not for the sake of getting the artifacts. No one cares about artifacts on your local build. You run the local build to get feedback. And if you skip the tests, you skip very important part of the build. How about we skip compilation? I mean, the build will be faster, and then it will just sources to production and compile them there. What can possibly go wrong? It's exactly the same absurd of giving up very important feedback for perceived speed. What we really want is faster feedback, not less feedback. So what feedback do we want? We already spoke about compilation, type of feedback that we want, tests, another type of feedback that we want. The place that we gather the most feedback is our CI/CD quality gates. This is where the most feedback gets gathered. So what do we gather there? Stuff like it compiles, unit tests are passing, integration tests are passing. Code coverage is good. The code is written up to the standards of our organization, and static code analysis finds bugs or, well, doesn't find bugs, right? And then we have security requirements like dependency scanning that is passed, secrets, we don't put passwords in our code, and stuff like security checks for what it's called, SQL injections, this kind of stuff. Non-functional requirements like load testing, it can stand the load that we want it to stand, the resource utilization, it won't waste too much of our money, and the compliance, it passes like all the compliance requirements, we don't have credit card numbers in the logs and this kind of stuff. So this is where we get our feedback, usually, most of our feedback in CI. The problem with CI that while it is very good in collecting feedback, it is not very good in providing it when we need it. And that's because we have two types of feedback. We have asynchronous feedback and synchronous feedback, and asynchronous is CI/CD. We never wait for it, but when it failed, the results are distracting. Right? So usually we run our local build, and it passes, and then we deploy our code to CI, and then we go to do something else. We're up to our next task. But if CI fails, it will kick us out of our flow to get back to what we used to do to fix it. I spoke yesterday with Josh Long. We recorded an episode of his beautiful podcast. If you want to hear it, it's on his Twitter and mine as well, at @jbaruch, so you can go there and watch the episode. And he told me, you know what? After I kick off the CI of my commit, I cannot really concentrate. It kind of sits on my mind that I need to monitor CI and wait for it to fail in order to go ahead and fix it before I can fully emerge in my next task. Why is that? Because his build, local build, didn't give him enough peace of mind that his code is going to pass CI. Because the amount of feedback that he gets from a local build is significantly less that would give him confidence that it will pass in CI. So CI checks a lot, but if it fails, it's very, very distracting. Synchronous feedback is our local build. We will wait for it in the flow. And Josh said yesterday, well, 45 seconds, it's about the threshold that I can wait for the build. And then I get distracted and go do something else. So if your build is slow, you will be really, really annoyed with it. The line between synchronous and asynchronous is the commit time, right? So we have our IDE and our build that we wait for, and then we have the CI and the production that we don't. And the ideal amount of feedback in our local build is exactly the amount of feedback that ICI gives us. If Josh had that in his local build, he wouldn't care much waiting for the results of CI. Because CI checks the same, he just checked it. He knows that all this passes, and then he can fully immerse himself in his next task, be productive with his next task, and not anxiously waiting for CI to see if his code is good or not. So getting more feedback during the build, this is our goal, and not skipping tests. But obviously there is this trade-off that it will obviously slow the build down. The more checks we add, the longer the build, it will be slow enough that we will start to multitask, check our Twitter, check our email, get out of our flow. It will take 25 minutes to get back in. It's terrible. Now, what we really want is both. We want to provide maximum feedback. We want to build that provides maximum feedback and also very fast. There are two main techniques to achieve that. The first is skipping what can be skipped, but no more. We only want to skip stuff that doesn't affect our feedback. This is called avoidance techniques, and there are a number of them. The first is incremental build, that the idea is don't build what didn't change, and don't build or test what wasn't affected. And this is your basic incremental build that is now available for many years, both in Gradle and Maven and Bazel and you name it, everywhere. Now, there are shortcomings of this naive approach. Because to determine what didn't change, the incremental build relies on produced artifacts. But this is not all the build does. And this is not all that it might change from one build to another. It also relies on architectural decisions. To know how modules are connected and which module depends on another one and needs or doesn't need to be rebuilt, this is learned from the layout of your project. But this is purely architectural decision. But project might be different, and sometimes the naive approach of incremental build won't recognize the right dependencies between those modules. A better technique to not build what needs to be built is caching. Caching makes the build faster, obviously, because you cache what you already done and don't do it again. And it makes the build faster for everybody, because cache can be shared between developers that work on the same project. So if I build it once, you don't need to build it. You can just rely on my caches if you didn't change this code, if only I changed it. It makes the build faster always. It doesn't rely on architectural decisions of modules, and it doesn't rely only on artifacts. Steps like that doesn't require generating new files can also be cached, as long as we can express the inputs and the outputs of a task in any kind of hash number. It doesn't have to be artifacts. And it makes all parts of the build faster, because it's not only for parts that are generating artifacts. And here is an example. This is a screenshot from Gradle tool called The Velocity that provides insights on your build and also provides stuff like distributed caching and what's not. And here's an example of a project that was sped up. It's cut here a little bit. So build time is 17 minutes and serial execution is 20 minutes. There's some parallelization going on. We're going to get to it in a second. Avoidance settings is 14 minutes. We saved 14 minutes. Out of those 14 minutes, the up-to-date, this part, this is the savings that built-in, just spoke about it, incremental build provide us. So this is your incremental build savings out of the box with any build tool, and it is 1 minute 58 seconds. Local build cache, 9 minutes. Remote build cache, 3 minutes. Out of saved, so the entire build is 17 minutes. We saved 14 out of those 17, so we're back to 3. And out of those 14, 12 is caching, and only 2 minutes is the out-of-the-box incremental build. So caching provides tremendous savings, and you really need to take advantage of it. Another technique in our avoidance section is predictive text selection. Predictive text selection learns how de facto code changes affect our tests. What real changes in our real code will fail which tests? And then, if it learns that certain types of changes in certain parts of our code won't affect the results of the changes, the results of the tests, we don't have to run those tests because it will be no difference anyway. The way it works is that it learns, the model learns what change and where, and then it correlates it with the observed test failures, and then it builds a model that predicts which changes will fail which tests. Couple of examples of this big magic that is really mind-boggling, because this is machine learning, this is not human reasoning, is the more tests a project has, the less they break. This is absolutely obvious for us while we apply reasoning, but for a machine learning model, this is a very strong observation. Another one, my favorite, refactoring in Java break tests less than refactoring in JavaScript. Again, for us, we applied the reasoning, we know what the compiler does, and it makes perfect sense. But the machine, all it did, it observed behavior of manipulation of files that has the .java extension, compared the behavior of manipulation of files that has .js extension, and made those conclusions that are absolutely in line with our reasoning without any ability to do reasoning. This is very nice. So here is how powerful predictive text selection is. This is a screenshot from Spring project. If you go to ge.spring.io, and you know where to find this link right here, you will see exactly this picture. Fortunately for us, unfortunately for them, Spring runs predictive text selection in simulation mode. What it means is that the model is keep learning and making conclusions, but instead of relying on it to only run small percentage of the tests, the Spring team keep running entire tests. If you ask any of us at Gradle, we will tell that it's stupid and they're wasting their time. But for having this screenshot, this is brilliant, because only in simulation we can show what the predicted tests behavior, how it correlates to the real test behavior. And we can see here that it predicts test goals, failures, with 99.4% of accuracy, and the tests themselves, 95.6% of accuracy. This is insane. And the time that the Spring team would save by turning this feature on and running it for real and not in simulation is over a week, and this is the last 7 days, the team will save 6 days and 4 hours in savings through the entire team. Like, let's say they have 10 people working on a team, so they will save one person's week by just turning this feature on in the velocity. Now you might say, hey buddy, but what about those 5% of tests that actually fail? And I will remind you that we have CI for that. This is local build. We speed up our local builds, but then, because we care about the speed of local builds, because we wait for them, but then we let the CI run all the tests, because we don't care the speed of a CI to a degree, because we don't wait for it, and this is absolutely fine. So we run those savings on our local build, and then we let the CI do the entire thing because it's fine. So once in a while, we will be distracted by a failed build. But the rest of the time, we will have local build time savings, which are critical for our developer productivity. So we cached everything we could. We skipped all the tests that we could. In the end of the day, there is work to be done. We wrote some code. We want to test how, by running build, we want to test how good it is. So we really need to speed up what cannot be skipped. The first and the most important saving that we can get is test parallelization by using the max power of our local machine. And this is why your boss should buy you the bleeding edge. I have a project on this machine that the tests run for 2 minutes. And this is obviously the majority of the build. You can see that it takes the significant part of the build. Now, I change one line of my build setup, and I get from 2 minutes to 10 seconds. This build is 12 times faster than this code, and the only line of code I add is this. Now, how many of you use the max parallelization of your machine for running builds? You don't. It's fine. Only a very small percentage of people do. The reason why I'm standing here is to make sure that you do that first thing Monday morning. This is out of the box. This is free. This has nothing to do with Gradle, Velocity, or any other commercial product. You come, you do that, and your productivity improves dramatically. Now, you know what has more computing power than your local machine? The cloud. So the concept of running tests parallel in the cloud has been with us for some years now, and this is called fan-out in CI, right? So when CI runs, it spins those agents and run the tests on them, and then collect them, and this is how you speed up CI. But just a reminder, speeding up CI is a nice goal, but it's much less critical than speeding up your local build. So shouldn't you enjoy that for local tests? They're actually much more important to do it on local tests than on CI tests. So you can use the cloud to distribute the test load, and then you can run all the needed tests faster instead of skipping them. And in cloud, test distribution is something that the Velocity can provide to you and your team, speed up your local build. And it's different from CI because it's a part of your local build. When it's time to run tests, your local build will decide what will be the most time-efficient way to run tests. Maybe the tests are so small and so fast that it will keep it on local machine. Maybe the tests are slow and need to be distributed and run in the cloud, and the overhead of sending the tests there, running them there, and collect the data actually worth it in terms of the gains of speed to do it, and it will do it automatically. Maybe it will do a mix of those. Some tests will be running parallel using the max power of your local machine, and others will be sent to the cloud, but you will speed up significantly your tests. And this is very important. And the third part of our path to foster faster feedback and our developer productivity is observability. So we need to observe and improve where it stands. So measure local build times across times and environments. You need to know what's slow, and then detect down-facing trends, and then find the root causes and improve. And again, this is the velocity that shows you the trends. This is boiling the frog, right? The time of build is slowly going up without anyone actually noticing it, but eventually it goes dramatically slower, and this is something that you need to be able to find and observe and do it. Again, you don't have to do it in the velocity. Measuring local build times is as simple as just paying attention to this number that you have after each and every build and put it in a spreadsheet and then see the trend. I mean, obviously, using better tools is better, but you don't really need to do anything commercial to be able to monitor local builds across times and environments. And frankly, the impact is there. 84% of the teams that we asked that started to work on developer productivity engineering report dramatic improvement. I guess the same 84% report developer joy. That's my favorite slide. It has the word joy on it. Developer joy, this is exactly what we want. Now you can say, well, developer productivity engineering isn't really my job. It's not on any of your jobs, right? This is, again, very familiar argument. It's like saying DevOps is not my job. But we just learned for an hour and a half that DevOps is everybody's job. Isn't it the case with DPE? Well, yes and no. So the outcome of DevOps is product. Released faster, better, and what's not. The outcome of developer productivity engineering is more productive work. It obviously correlates to our ability to release the product, but it's not directly the same thing. And then it obviously dictates the urgency. DevOps been on everybody's mind for the last 15 years because we see the results in better products to the market faster. DPE trends to step away. Even if I got you excited in making your build faster, you will come on Monday and you will work for a couple of days in improving your build. Next time you look at it will be like in a couple of months at least. So it does slip away. And this is why it requires specialized team that will be in charge of it in your organization. And the best DPE organizations build focused teams. Teams like, you know, Snowflake are hiring for developer productivity engineering. LinkedIn are hiring for their productivity and IT group. Microsoft are hiring for platforms and engineering productivity group. Platform engineering is very tightly related to developer productivity engineering group. Spotify have blogs about how successful they are with improved developer productivity for our DevOps teams. Ouch, DevOps teams. Netflix hiring for their developer productivity, etc., right? So Elastic and who's not. So developer productivity engineering requires organizational mindset. But what you can do as individual contributors are be the developer productivity engineering agents of change. You can talk about it, you can show it, and eventually you can prove to your organization that this is important enough to pay attention to. So let's sum it up. We're talking about evolution. We're talking about movement from the ancient ways to the new ways, both in DevOps, in platform engineering, and in developer productivity engineering. Right? DevOps, as we started, truly mainly solves ops concerns. And it is a collaborative technology and not engineering, and it needs engineering implementation. And this engineering implementation, no matter how you call it, SRE, you shouldn't, platform engineering, you really should, it's someone who needs to set up Kubernetes and run on those YAML files. But what about people productivity? This is where developer productivity engineering comes in and provides another pillar of DevOps engineering implementation. With that, you can try improving your build immediately and dramatically with what we call the Gradle or Maven Speed Challenge. You can speed up your build, or if you don't want to mess with your production build, you can try it on an open source project, that or another. You can be the DP agent of change, what we spoke about, and talk about it with your colleagues and your boss, and more details about developer productivity engineering in our DPE handbook. DPE Summit last week was an amazing event, 600 people sold out, 2 days of pure developer productivity engineering. We are working on releasing the videos. The keynotes are already published. If you go to Gradle YouTube, you can see the 4 keynotes that we had there that are already up there, and learn more about DPE from there. With that, I'm at jbaruch on Twitter and everywhere. This is at Dev2Next. DPE is the hashtag that you mentioned when you praise this talk, and speaking.jbaruch is where you go for everything, including the video. And now, we're 1 minute late for lunch. How about that? Thank you very much. And I'll make sure I upload the slides right now with the video. So if you check